Bismillahirrahmanirrahim. This video will be discussing example 14.2 and solving practice problem 14.4 from Mr. Hayt's book of Engineering Circuit Analysis. And this is on the request of a student. Okay, this question belongs to Laplace transform. So let's learn or recall the two formulas that we have studied. The first is two-sided or bilateral Laplace transform. So this is the formula: integral from negative infinity to positive infinity, and the function ft is multiplied by e power minus st. And the other type is unilateral or one-sided Laplace transform. The only difference is that the start is from 0 instead of negative infinity. Okay, so let's first of all discuss the example of 14.2. Compute the Laplace transform of the function ft is 2ut minus 3. So the first thing we'll do is understand what is ut minus 3 means. And the easiest way to understand this is, we know u is for unit function and t minus 3 is shifting. It has, the unit function has shifted, but shifted on which side? Positive side or negative side? For that we just put t minus 3 equals 0, and therefore we get t is equal to 3. That means the shifting is towards the positive side. As we'll do, this is our line, our axis line, and now the function will start from t is equal to 3. So like this, as shown here. So this is our ut function, and before this the function is 0. So obviously, since there is no function before 0, therefore we'll be using the one-sided Laplace transform, which starts from 0 to infinity, est ft. And now I'll plug in the value of ft. So ft is 2ut minus 3. We take out 2, then this is remaining. And now from here you can see that the function is not starting even from 0, it is actually starting from 3. So we'll put this limit to be 3, and ut minus 3 will be equal to 1. So limit starting from 3, this is 1, so 1 multiplied by e minus st is e minus st dt. And now we'll take integral of this, and I hope you know what is the integral of e raised to the power minus at is 1 divided by minus a. So in our case minus s, so 1 divided by minus s. That will be 2, this 2 divided by minus s, e raised to the power minus st, and we'll put these two limits. Now plugging in the values of the limit, we get this relation. Now remember, e power minus infinity is 0 as shown here. E minus infinity can be written as 1 over e plus infinity, and e power infinity will be obviously infinity. So 1 divided by infinity will be 0. That means e minus infinity will be equal to 0. So we'll put 0 here, 0 and minus e raised to the power minus 3s. We have put in these two limits here. So our answer will be this minus and this minus multiply plus, so 2 over s e raised to the power minus 3s. So that is the final answer. Now let's move on to the practice problem. The practice problem has this function given, and we have to find two solutions. One, part A is two-sided Laplace transform, and part B is one-sided Laplace transform. So part A, and this is the formula for two-sided Laplace transform we have learned. Now we have to input the function. So inputting the function, this is the whole function plugged in, and we take -6 outside, therefore it will be integral e minus st multiplied by e minus 2t. So multiplication, the power will be adding, so it will be negative s plus 2t, and this thing remains as it is here. So we were here, and now we can separate these two parts, -6 outside, then bracket integral this multiplied by the first part, and similarly integral and the second part. Okay, now we'll understand what is ut plus 3 means and what is ut minus 2 means, as we did in the previous case. So ut plus 3, we'll put t plus 3 is equal to 0. That means t is -1. That means this function will start from -3. T is equal to -3, so it will start from somewhere here, as shown here. So starting from -3 and going all the way to positive infinity. So this implies that our limit, instead of negative infinity, it should start from -3, because before this function is 0. So anything multiplied by 0 will be 0. So that is one thing. Similarly, ut minus 2, same logic. Here, now t will be equal to 2. That means this function will start from t is equal to 2. So in this case, the limit now will be from 2 to infinity. Okay, so putting the limit -3 to infinity, and in the second case 2 to infinity, and since t3 is actually 1, therefore 1 multiplied by this function. So this is what's left here, and similarly on the second part. And following same technique that we did in the previous case, the integral of this will be 1 over this power, so it is 1 over minus s plus 2 e raised to the power minus s plus 2t, and the limit is from -3 to infinity. Same case here, it will be minus and 1 over minus s plus 2, this function, and the limit is from 2 to infinity. Now plugging in the values now, or we have just taken both of these being same, taken them out, and so now we can plug in the values. So this one is e raised to the power minus infinity when we put t is equal to infinity, and when we put t is equal to -3, then minus plus, so it will be 6 plus 3s. Similarly here, e raised to the power minus infinity, and when we put 2, then it will be e raised to the power minus 2s minus 4. And as we had discussed earlier, e raised to the power minus infinity is 0. So we put 0, and there is no point writing 0, so we just write this value and the second value. This will be negative into negative will be positive. And this can be rearranged. Positive first and then negative. So this is the answer for the first part. And answer given in the book is this, so we have same answer. Now we come to part B. Part B is one-sided fs of the same function. So starting from 0 to infinity, or 0 minus to infinity. This was the function that we had done for the previous case. Now what will happen is that instead of -3, it will now start from 0, because one-sided is starting from 0. So that is the only change. This part remains unchanged. So we have put in 0 here, and rest everything is same as we did, as the limit change. taking these two out common and putting the value of 0 and infinity. Now this will be 0, e raised to the power minus 0 is 1. So we'll have 1 here or minus 1 here, and we'll have minus e raised to the power minus 4 minus 2s. And we can write the positive term first and the negative term later. So this is our final answer. And this is what we have in the book also. So I hope you have been able to follow this. Please let me know through your comments. Thank you.